everyone. In this lecture, I will explain Laplace transform of unit step signal, ramp signal, impulse signal, and exponential signal. Here's the problem is prove that Laplace transform of function of t equal to 1 by s when function of t equal to unit step signal. In solution, we can write from Laplace transform L of function of t equal to integration of 0 to infinity e to the power minus st into dt. That means Laplace transform of unit step signal e to the power minus st into function of t is equal to u of n to dt. If we draw the unit step signal, that means the value is 1 and the range is 0 to infinity. That means integration of 0 to infinity e to the power minus st. The value of unit step signal is 1 into dt. E to the power minus infinity, that means 0. That means e to the power minus infinity is 0. The final answer is 1 by s. That means Laplace transform of unit step signal is 1 by s. Now, Laplace transform of ramp signal. By definition of Laplace transform is L of function of t equal to 0 to infinity e to the power minus st into function of t into dt. As the function of t equal to t ramp signal, that means here's the integral formula is here's the formula is integration of uv formula. T into e to the power minus st divided by minus s. The range is 0 to infinity as integration of 0 to infinity 1 into e to the power minus st divided by minus s. That means the final result is 1 by h square. That means the Laplace transform of ramp signal is 1 by s square. Now, Laplace transform of impulse function. Prove that Laplace transform of function of t equal to 1 when function of t equal to delta n. Here delta n is a impulse function from Laplace transform L of function of t equal to integration of 0 to infinity e to the power minus st into function of t into dt. That means Laplace transform of delta n equal to 0 to infinity e to the power minus st into delta n into dt. If we draw the impulse function -1, -2, -3, here the value of delta of n is 0 everywhere except t equal to 0. T equal to 0. When t equal to 0, delta of n equal to 1. The magnitude is 1. That means Laplace transform of delta n equal to delta of 0 equal to 1. That means that's why the Laplace transform of impulse function is 1. Now Laplace transform of exponential function. Prove that Laplace transform of f of t equal to 1 by s minus a, where function of t equal to e to the power at. L into a to the power at equal to integration of 0 to infinity e to the power minus st into function of t, that means e to the power at into dt. e to the power minus s minus a into dt. E to the power minus s minus a to 0 to infinity. That means the final result is 1 by s minus a. The Laplace transform of e to the power at is 1 by s minus a. Now prove that Laplace transform of function of t equal to 1 by s minus ia, where function of t equal to e to the power iat. From Laplace transform of function of t equal to 0 to infinity e to the power minus st into function of t into dt. That means Laplace transform of e to the power iat equal to 0 to infinity e to the power minus st into e to the power iat into dt. Minus st plus iat into dt. One by minus s plus ia and the limit is 0 to infinity. E to the power minus infinity equal to 0 and e to the power 0 equal to 1. That means the final result is 1 by s minus ia. The Laplace transform is of e to the power iat equal to 1 by s minus ia. Here's I ending my lecture. Thank you.